Stu, so this is kind of how you modify a user interface element like a slider. So right now we want life extension to go down to 0. So all I'm going to do is right click on this element and hit edit and change that to 0. And now you can see that's the increment and then the maximum. And you can see now that this guy should now go down to 0. And we were on version 30, so the other thing I just do is pump up the version number, which is over on this code tab, just so whenever you're looking at something, we can make sure you're on the right version there. So we set our version right here. I'll set that to 31. And this also just gives you a sense of the full length of the code. If someone was to port this, for instance, when you see, handle this transition, we call, Stuart just labeled these with letters. Handle A, basically we're an electron plus an antineutrino, creating anti-quark and just changing the color of the anti-quark. Or here's one where it's creating positrons and neutrinos. So this is asking all the quarks that are old, if you're less than some random float number, make a positron, and then so make a positron 1, and then this is now kind of this is what happens when it's instantiated. It'll register its birth, and it will set its color, and we'll go ahead and then also hatch some neutrinos. As you kind of look at this, I've just put in one line just for convenience, but these are really 3 separate commands going on here. So that just gives you a little bit of an idea there. And if you have any questions, we can talk about it. And this version later, that compared to what's on the web, was also calculating R-squared fits on these bits. So there's a little bit more going on that's on the web. And also this also had a built-in parameter sweeper that we're doing here. If you want to stop, this was also stopping at 30 runs. And I'll set that up and go. Now that will stop at 100. If I don't want it to stop at all, I think I can set that to 0. And I'll set up and go, and then that'll just keep running. And if you can keep your eye on your memory use, and you can allocate more memory to Java in the beginning, but basically we're looking at our counts of particles here, and you can see that thing starting to slow down over time. There's a place where we're setting random seeds and things like that. But that should be it. And I'll just kind of show you where this behavior space is. This is for parameter sweeping. So if we come into the tools here and find a behavior space, you can see we've already done some parameter sweeps back in January. For instance, this did 3,600 runs, and we'll go look at that experiment. So you can make an experiment, and just kind of walking you through here, we can say it automatically grabs any kind of global variable or slider. So if you see a number here, that means I'm not changing that, but the R, I'm going from 0 to 0.01, 0.1, 0.2, and 0.5, and then doing the combinatorics with G having these values. If you see 3 numbers in here, instead of just a list of numbers, like that's just a list of numbers, but if you see like 3, then that's saying B will go from 0 to 1, stepping every 0.5. So you can actually get like three values, but you can be very have a really small interval to go there. So that would be now sweeping that, and then per run, we don't want to put out the results every time step, just at the end. And I'm putting out these statistics, and we can put those out to a CSV or a spreadsheet. and it was typically stopping after 7,000 particles were created. Turtles is a kind of a legacy term out of MIT with Seymour Papworth's group from the Logo language. So all particles are turtles. But you can also name them whatever you want here, which you'll see in the code I do up here. So anyone that's kind of done NetLogo, and it's a good teaching language, by the way, is here. So I'm going to go ahead and save this, Stu, for you, and I'll send it in an attachment. And just one other thing here, just as I started off from scratch. I made a new thing here, and I'm just going to open up the model libraries here. And if you look just in physics here, you can see there's some basic lattice Boltzmann in here. Where were some of those? Let's see if I can just do a search. Okay, so at least lattice gas. They had a lattice gas automaton. Just to give you an idea here. And this is the info tab. And the nice thing then, if you ever just want to make this on a web page, you save it for the web. It gives you a single file, and you can put it up on a server. So that's what you were seeing earlier. All right, with that, I'll close this out.